and my presentation is influenced by two things. One is I had some discussions with my dear friend Avinash, and then we were discussing that we should also encourage the collaboration from my institute. So I changed my presentation towards introducing what my other colleagues are also doing, number one. And number two, I believe in two kinds of collaboration. I am a material scientist, worked on catalysis, so I collaborate with catalysis scientists, and other collaboration like with Professor Avinash, wherein we look for the complementary expertise. So that's why I haven't written anything on my sheet, but we'll take care of mostly emission related things. So this is what my perception will be from a point of view of my institute. So my institute, I'll very quickly introduce as an environmental engineering research institute, wherein we are working on different aspects of air pollution. Thank you.
We can continue. We are trying.
Or not very specific to the automobile emission control. So I would like to show you what we feel as a neutral person or as an expert in the area of environmental engineering or air pollution control, not exactly the automobile pollution control. Fine, it works fine. Thank you. So recently we started looking into the emissions from combustion sources, and interestingly there are different claims. Second, can direct biomass solid fuel combustion be sustainable? Because I'll show you the reason. Efforts towards e-fuel development at my lab and the mobility emission control. This is the area I extensively work on in fact, and I'll look for anything. And we have done two interesting studies to check the emissions from the old vehicles. So this is my institute. It's one of the CSIR lab. CSIR you can compare with CNRS France. We have 37 labs in different areas of research. So National Chemical Laboratory, National Physical Laboratory, so on and so forth. So my institute is dedicated to environmental engineering and environmental sciences. Obviously we have different departments focusing on air pollution and all these things. Yes, so recently about 8 years ago, we established energy resource management, because energy is one of the biggest contributor to the pollution. And then we have water, wastewater, biology department. This is the department or division I look after, and we have quite a few activities. I have been working actively on automobile emission control and something to do with the VOCs control or indoor air pollution. A colleague of mine works on fuel cell. This is something interesting we are exploring. Chemical looping combustion, because we believe that for a short term, in Indian perspective, or mid term, like 20 years, I think the gray, blue, and green, all the kind of fuel will be there. And why not to make the efforts? Then this is something interesting. We work on the cook stove, which nobody wants to work now today. A bit on the CO2 reforming, which would be of interest to this conference. And we are into a lot of drone AI ML applications as far as environmental engineering is concerned. This is how we used to look into the air quality management maybe 10 years or 20 years back. And the difference was there was hardly any importance to the greenhouse gas emission, the climate change, and urban hotspots, while PM emission, I would say, is still a challenge. So quite often we have a debate that whether the PM is important or the GHG emissions are important. Like many of my young colleagues comes to me and they say they have been working on the PM emission. They say, but we want to work on the GHG now. And the reason, you get grants easily on the GHG. While if you ask me, or you don't have to ask me, what is the big challenge of India today is the PM emission. I mean, the PLE and everybody knows that we have been facing a challenge of this thing. So the relationship, these are a few basic slides. So if you know that, please ignore. This is how we perceive the relationship between automobile and the environment and energy issue. One is the air pollution problem, where we don't want to give less importance to the PM emissions. Of course, GHG is a big issue. Carbon neutrality is a big issue. The waste disposal, the global warming, and of course the traffic accident and safety. So a colleague of mine also works on the life cycle assessment of all these emissions. And I'm sure you know the story of how the automobile engine was developed, wherein there was a lot of horse dung, and they say, okay, we are taking care of the pollution, and what it emits is a small amount of smoke from the automobile, which now today we are struggling to control. If you're not familiar, a couple of weeks back, this article was published, which was discussed in detail, a bit of a controversy it created, okay, wherein normally in the month of November, we have a lot of activities in Delhi because of the pollution problem. And this particular article from IFCPAR and a couple of other sources, they say when it comes to the combustion-related PM emissions, okay, only combustion-related PM emissions, half of the contribution is from solid fuel burning, out of which about 10% is for the heating and roughly 40% is for the cooking. And here you can see the claim that close to 29% is for the industry, 6.5% is the crop utility burning, 8.3% is the power, and transport is about 7%. So we have invested in Indian currency like roughly 1 lakh crore on Euro 6, and we know that automobile industry as well as the government has done extremely well moving from Euro 0 to Euro 6 today. Okay, and we know why, because that industry is a very organized industry. It has got an international, like multinational companies, so they were able to control the automobile emissions. So although we have to make efforts, but this is one of the inventory distribution wherein we need to focus. It should not happen, of course, for the climate change perspective, we need to work on what we are doing, but we cannot ignore these kind of emissions. I work extensively on the solid fuel combustion, and we know that this figure could be 35 or 38, but not less than that, for sure. So, as a national lab, we work quite actively, although today we have a very impressive LPG program, very impressive electric cooking program, but this is a typical case of energy transition. And in any developing country, the energy transition takes its own course. Could be 10 years and could be 15 years. There's something called just transition, all of us know, and we need to reduce the emission during the energy transition. We cannot expect that we have a solar growth, so next year onwards, we can shut down all the coal-based power plant. So this is an ignored area, but as per the very recent survey of the Government of India, the Madhya Pradesh has got a 24% access to clean cooking fuel, and the Chhattisgarh just 20%. So we look quite extensively on this because this is causing a lot of health damage and the environmental damage. And another issue is the black carbon, which also contributes to the GHG emission. So what we have done, we have developed our own cook stove. There are plenty of cook stoves in the market. We have already got almost 50,000 distributed, and the cost-benefit ratio is very good. So in addition to other combustion sources, we need to comprehensively look into the other, like solid fuel combustion as well. So being a national lab, we are pretty much technology agnostic and the fuel agnostic. And then recently in G20, we also contributed highlighting the advantage of the LPG, because there are many things. For example, I give you an example of cook stove, wherein a 2 years back report suggests there are 120 different pollutants. So we need to consider those pollutants as well. While in case of LPG, we need to also consider what are the other benefits. So there is a concept of FNRB, fraction of non-renewable biomass. If you consider the biomass as a renewable fuel, and if you consider the latest like cook stove technology, which gives you 45% efficiency or 50% efficiency, so there are arguments. There are arguments that this is a renewable biomass. Half of the biomass has to be utilized somewhere. Pyrolysis is one of the best way, but if you leave it like that, it leads to the forest fire also. So we get a lot of like pressure from the forest department. You should promote the cook stove. You should promote something. So this is a recent contribution from our group wherein we are trying to find out. Okay. Well, the next is what kind of work some of the groups related to our division only they are working on. We attempted water hyacinth conversion to the pellets and the briquettes. Here the challenge is we were able to convert into suitable fuel for like the tandoors we use or many other boilers. The challenge was we need to blend it with the sawdust or bagasse. Okay, and if you do it, it works fine, emission point of view, efficiency point of view. But in the water hyacinth, it contains 90% plus water, and that takes a lot of energy. So if you have some way, like especially the solar thermal we tried, especially in the Nagpur condition, for almost 6 months, you can achieve the drying up to the level. And 15% is anyway required for the briquette. So this we are trying that whether we want to compare whether the pyrolysis or simple conversion in the pellet, while the government is promoting almost 5% of the co-firing in the power plant, okay, while the pyrolysis might itself take a lot of energy to produce the better fuel, how does it work? So this is one thing we have done recently. The second thing, we are working on pyrolysis of bamboo waste. Bamboo has been promoted by the government, and there will be a lot of bamboo waste. So there is something called Maharashtra Bamboo Development Board and industry. So with the help of that industry, we set up about 500 kg bamboo biomass. There has been lots and lots of research. What we are trying to do, try all the three products, the solid, liquid and the gas. Try to work out which will give you what kind of energy input as well as the money, okay. So biochar is interesting. If you activate it, it has got some commercial value. The pyrolysis oil, we have decided we'll just pass on to our another lab, Indian Institute of Petroleum, and they'll try to find out. Right now we are not working on the pyrolysis gas. We are just taking the details from the literature, and overall a colleague of mine will work on some LCA-based estimations that how it will work, with some concepts of like fast pyrolysis and all which we want to try. So this is another area wherein we are looking into, probably we can call it an e-fuel, but some money can come from the biochar for sure. Coming to the last part, which is low-cost catalyst for diesel exhaust emission control. This is some stats from India, okay. So we have a huge number of vehicles, and this is just the beginning of our growth as far as even vehicle is concerned. So we would be having a sufficient number of vehicles which needs to be looked into. There are two kinds of basics of catalyst materials. One is to lower the amount of the noble metal because they are very expensive. This is what most of the companies is doing, and most of the companies have achieved a great amount of dispersion. There is a second, mostly restricted to the lab work, I would say, is a non-noble metal based catalyst. We are trying to avoid the noble metals. I'll show you why it is becoming a little more interesting, because now we are talking about the different fuels which might have a different, like the emissions, and we should have a good library. So this is one of the class of catalysts we work, perovskite catalysts. These are completely non-noble metal based. As I completely understand, this is not a material science or chemistry gathering. So I'll be very brief about this. So these materials have a lot of flexibility. You can play with the composition, you can play with the synthesis processes, so forth. Like even you can change the properties. A very lot number of compositions are possible. Okay, and many reactions it can actually catalyze. So there has been a renewed interest in these class of materials. There are a couple of challenges. One is the surface area is very low, so that's why these class of materials were not very successful in auto exhaust catalysis. Second problem is it is susceptible to SO2 poisoning. But with sulfur content going down, and we have a new category of fuels, probably people have started reinventing or reworking on these class of materials. So this is very typical, you know better than me. This is how it looks like. The suit, in fact, I have seen some very interesting pics of diesel particulate matter. There are two technologies commonly known. I'm sure Dr. Shaktivel and all are more than familiar with this. One is a diesel oxidation catalyst, wherein we expect, this is a typical soot particle where its soluble organic fraction is hydrocarbon, then there is a sulfate and all this. So this condensed gaseous mass can be catalytically oxidized. So if you have 40% SOF, your efficiency can be maximum 40%. If you have 20% SOF, only 20% will be efficiency. So this is typical like a gasoline catalytic converter. You have a catalyst coating here, the particle is passing through it, and it will only remove this soluble organic fraction. So the advantage is back pressure is almost negligible. It's a low cost device, but the efficiency is around 20 to 40%. This is very typical of this thing. The next very efficient device is diesel particulate filter. All of us know that filters with efficiency of 95% are available. Okay, you can just buy it and fit it. The challenge is regeneration. Okay, it requires regeneration, for which the temperature required is close to say 500 or 650 degrees Celsius. While being a lean burn engine, you have hardly 200 or 250 degrees Celsius exhaust temperature. So a catalyst is required. Very common mechanism is you are having an anode. NO get oxidized into NO2, and this NO2 reacts with the soot, and you get regenerated DPF. These are two very typical processes for regeneration, active and like active regeneration, you are introducing a fuel, but there will be a fuel penalty, and there will be CO2 emissions also. So the catalytic regeneration is always preferred because you are preventing the fuel penalty, which is otherwise required to heat up the DPF. So this is how it works. I explained to you. You want an NO, you oxidize into NO2, and the kinetics of NO2 plus soot is very good at a lower, even at a moderate temperature. So you again get an NO plus CO2, and this NO can be taken care by selective catalytic reduction, SCR. This is a typical criteria. It's a very tough applications. You need chemical stability, you need a thermal stability, you need a high surface area, and so on and so forth. So we work on these kind of compositions. Okay, this is one of the composition we attempted without or with just 10% of the amount of noble metal. So we do a lot of characterizations like XRD, temperature program desorption, temperature program reduction, which is commonly used for the catalyst characterization. And yes, after that, I'm skipping this because it's a bit of a chemistry which may not be of interest to you. So we go for the 3 levels of evaluation. First, using this fixed bed small laboratory reactor where we basically screen our catalyst, 10, 20, 30, 40 catalyst. Then we use a next level band scale facility, and third is an engine dynamometer facility. So this is a kind of a curves we get. This is without catalyst, so your soot is burned at about 500, 550 degrees Celsius, and with catalyst it is around 300 degrees Celsius. So you can use thermogrammetric apparatus or the apparatus testing I have shown to you. You work on mechanistics aspect, why it is functioning in absence of noble metal, what are these things. The next facility I use from the Kyushu University, where we have a band scale facility where we keep a small diesel engine here, okay, and it comes, and here we can keep a catalyst coated support, and you can measure the CO2 and other emissions. We are also trying for some operando studies wherein we try to explain the mechanistics aspects. Third is then after screening we shortlist 1 or 2 catalysts and go for the prototype preparation. Simple dip coating method we use. This is how it looks after the canning and all. So there are 2 set of results I can show you because of the short of time. This is 2 DOCs we prepared, promoted by very small amount of platinum and palladium. The size was a 2.2 liter substrate, and one was around 1.7. In combination, we also used ceramic filter. Okay, so there was a project between IIP and NERI wherein we tried to test it for the DG set using a very, very small engine, 5 kV engine. In fact, these are the load conditions, and these are the results. So for DOC plus DPF, percent removal for PM was also quite good without using, in fact, significant amount of noble metals. So why we want to use this kind of a material? Not for the new vehicle, because the efficiency requirement is very, very high. But for the retrofitment, probably this can be a good solution where cost is a sensitive issue. So the first kind of a trial we did with Professor Avinash Agrawal's lab in IIT Kanpur, way back actually, and we were able to publish also. The interesting part was he was probably one of the first to attempt B20 in India. And he was interested that, yes, we should try, why not we should try B20. So this was very encouraging for us that using a non-noble metal based catalyst, we could reduce not only the carbon monoxide, the total hydrocarbon, but even the particulate matter. It's only the first set of data. After that, he has done a lot of work, and many other reports have also come. But this was a big encouragement for us that even using the biofuels and probably the futuristic fuels, we should be able to control it, and if required to design new catalyst, there's a whole set of compositions available. Probably they might as well work in this case. The last thing is nowadays there is too much of talk. I think we are already at Noida. So generally they issue that the Euro 4 vehicle also cannot enter Delhi. Euro 3 vehicles of course out of question. There's a big debate going on. Let's throw these vehicles. Obviously, automobile industry will be interested in the new vehicle, but if you look at the LCA-based lifetime emissions, the GHG footprint of vehicle manufacturing is also very significant. So it's not a good idea to do that. So considering this in mind, we started working on retrofitment exercise, because we have close to 90% of the vehicle population which is either Euro 4 or below Euro 4. What is to be done with that? Because Euro 6 is quite clean, but we were not getting any significant improvement because 90% of our vehicles are Euro 4 or below Euro 4. So these are some of the reasons why we feel that retrofitment could also be one of the good strategy, okay, wherein we can target the most polluting vehicle which have already been identified, like the taxis which are emitting inside the city, because in addition to emission, we also worry about the exposure, okay. So all these taxi and city buses are plying inside the city throughout the day. So the probably first ever detailed exercise on retrofitment we did around 2013 with the SWRI and Johnson Matthey. Majority of the contribution was from Johnson Matthey. To be frank, I was only coordinating. So this is a city bus which we identified. It was Euro 1 bus, okay, and we tried these devices with the help of all these manufacturers. The first challenge was, as just now somebody pointed out, over the exhaust temperature. But the reason for low exhaust temperature was the traffic condition in India. So JM and Cummins and we put together, we measured the temperature, and it was a big challenge for them to design a device which can work at such a low temperature. So this is one concern about the retrofitment as well as for the new vehicle, because your exhaust temperature is quite low. This is another thing wherein majority of the time you get 200 degrees Celsius. While for DPF catalyst, you need at least 250 or 260, best of the catalyst. After we did some kind of insulation in the exhaust, there was an improvement about 50-60 degrees Celsius, and then we tried and we retrofitted these kind of devices. We put a lot of like artificial load into this, but this is the state of like DOC and DPF after a few days of running. And to the extent that it got damaged, this thermal damage, we checked, the temperature was around 1100 degrees Celsius or 200 degrees Celsius. Not only because of the failure mode, but the localized burning of a huge amount of like soot. So these were very big challenges. So we were very clear that we recommended that the Euro 1 vehicle were not really suitable for the retrofitment. Okay, although there were a lot of interest for US trade agency. Now there was another project recently given by the MOFCC, Ministry of Environment, Forest and Climate Change, which we are coordinating with ARI, wherein almost vehicle manufacturer, ECMA, Octane are interested. And again, we are trying for the new devices. But in this case, yes, the target was 50% PM reduction. We got up to 65% in one combination of DOC plus DPF. So now we propose that this is not enough. We need to do at least 6 months of durability trial, based on which we can possibly recommend that some of the buses of Euro 4 or Euro 3 can be retrofitted. Okay, and cost we worked out should not be a big problem. So we normally believe that these are the fundamentals on which we need to work as an environmental engineering institute. We need to reduce vehicle kilometer per passenger. There should be proper town planning and all these things. This comes with a lot of developments and improvements in the technologies. So I consider this as a typical environmental or economy environment growth, nexus, okay? Because obviously the automobile industry will look for the more number of vehicles, but there will be a limit in terms of exhaust temperature and other things. So in summary, the environmental challenges are getting severe. There are a lot of new and emerging pollutants we encounter, not really from the automobile, but from many other sources, as I explained you. But there's a very good amount of technological solutions are available, wherein there's a very good possibility we can actually take care of both GHG emissions as well as those conventional pollutions. So we shall be really glad to collaborate in emission control domain. I'm not from the engine, and of course I work closely with Dr. Avinash, and we got an Indo-French project with this. This is the group. So with this, I would like to thank especially to Professor Avinash Agrawal for giving me this opportunity to be here working together with me for several years. Thanks a lot for your patience. Sorry for taking 5-10 minutes more.
So maybe we can have 2 to 3 very quick questions.
No, really a question. It was a great presentation because really we understand
Absolutely. I mean, the efficiency is the buzzword today. Everybody has pointed out. I mean, the kind of efficiency we have, let it be the electrical appliances or automobile. Automobile is slightly better because we are directly combusting the fuel. But yes, one is efficiency, and second is we need to find the ways for the mass transport. That is going to. The only thing is now we are targeting the gross polluters. Like the city buses or the taxis, which run inside the like the cities, and they emit entire pollution inside the city rather than intercity buses.
It is the same in Europe. We try to develop what we call the, I don't remember in English, but it means that we will have some area without any pollutants. So it's
Yes.
very pollution.
Also,
But it is very, very difficult, and even if some cities say, yes, we will do it in 24, they stop because there is a social problem. The social problem, we have some people who have to work in the city and they have no sufficient money. They cannot buy Euro 6 or clean engine vehicles. It is the
True.
same in France. We have the same problem, and it is really difficult. We have to help these people to go to work, to live.
yeah, we should have an efficient, the mass transportation system. I haven't covered about the INC, inspection and certification, which is another bottleneck which has given a bad name to the IC engine, which are really not polluting, but the kind of a maintenance we have in this country, it becomes polluting vehicle. Yes.
Thank you for very nice presentation. So, did you consider the lifespan of a diesel vehicle while looking for Euro 2 retrofit? Maybe it is 10 years or something.
Right now, it is 10 years in say NCR, okay, in say Maharashtra, in my city it is 15 years for diesel vehicle, okay. But we do not have really exhaustive data of the old vehicles, although ARA made some attempt, even the TERI made some attempt. So initial emission factors for say 5 years old vehicle, or rather a vehicle which has done 100,000 kilometers, is not there. So what is required is we should get the emission factor, but this retrofitment approach is like what is the return on investment? Like we have a device over 50,000 rupees which you retrofit in a taxi with a life of say 5 years, it will have a huge environmental benefits, no less than 200 times. So yes, the normal durability is now close to 2 lakh kilometers probably for these kind of devices, okay. So those retrofitment devices are available. The only challenge is whether the vehicle is suitable for that. So we had a Tata on board, and they say probably Euro 4 will be suitable vehicles without much changes, but Euro 3 there are concerns.
Okay, one more question that you have discussed about diesel oxidation catalyst and diesel particulate filter temperature, like 600 or let us say what about 350 or 400. But these days people are looking for low temperature combustion, and the temperature in the exhaust pipe is lower than that. So are you planning to do any work for the oxidation at low temperatures?
I actually do not work. Of course, the catalysts nowadays work at a very low temperature because there is a low cold start regime we already have, and everywhere in the world low cold start regime is there. So for gasoline based sort of emission control devices like catalytic converter, they work at pretty low temperature. Coming to your question, which we discussed in the previous talk also, how do you feel that whether you are able to sort of utilize this thermal energy into mechanical energy and then compromise on the catalytic converter? That will be a very good idea, because if required, you can really heat up this small device.
So what is the value like low temperature, like 150 or?
Yes, it gets activated at about 150 degrees Celsius, and for diesel around 250 to 275 is what is required.
You mentioned about this perovskite-based catalyst.
Yeah.
So what is the maximum temperature up to which this catalyst can be operated? The maximum temperature?
Actually, the maximum temperature is not a problem, because the synthesis temperature itself is about 700 degrees Celsius. But the compromise is because these catalysts are synthesized at high temperature, you lose the microporosity and you lose the surface area. So surface area is a challenge. You need to put in a larger device, okay? Surface area of the catalyst is a challenge. So we use different techniques to improve the surface area.
In one of your slides you mentioned that the populations, like in Madhya Pradesh, it's only 20% of the populations have access to clean fuel. So does this mean they don't have LPG? 80% of the population doesn't have access?
You know, like last 10 years, the LPG penetration has been really good, phenomenal, okay? But there was a slippage also because of the affordability issue. Recently, like there were a lot of announcements before the election, I should not say, okay? But it has come from, like Chhattisgarh must be around 5%, so it has come to 20%. There are states which has progressed from 15 to almost 60%. But because of the affordability issue, according to IEA, like International Energy Agency, it might take about 10 to 15 years when we can think of 80% of this, while they are also now introducing the e-cooking, which will take care of almost electrical cooking.
Long live India and France friendship.